All right. How's everyone doing this fine Wednesday night?
Good. How are you?
Doing good.
Great.
I like that. We had our first rain since the hurricane here, so everything's wet outside, but hopefully the temperatures will stay low. Real quick, before we begin tonight's going to be a lot of just we're going to talk real quick about code for week 5 because it's just adding some inner joins, and actually your exercises for this chapter are all about unions. Very few for outer joins, and then we'll go ahead and design another database set and just fill any questions. So before we begin, a number of you have sent me. You've been creating the databases in Workbench, which is fantastic. And you've been sending me the MWB files for me to look at. I can't open those. There's something weird about the security of MySQL. If you send me a MWB file, I can't open it on my computer. So just send me the ERDs. I just need to see what it looks like. I don't need to, if you can do a screenshot of it or you can export a picture of it or whatever it is, just don't send me the MWBs. And I say this now because for the final project, everyone always sends me MWBs and I can't open them. So save your upload time. Just send me the picture of the ERDs. Okay, so let me go ahead and share my screen. Share screen. Okay. Before we get to that, let's look over here. So this week it's about, they're saying it's intersection, but it's really talking about unions because you can't intersect and you can't intersect and you can't accept in MySQL. This week's paper, let's see. If you're not doing the final project, your boss is giving you a new task. You should qualify what you learn about set theory and practice and explain how the process of joining sets differs between join operators and set operators. You should also qualify how to exclude the intersection with combination of set operators. You should return. So basically this is saying, talk about how joins work. That's all this is asking you to do. Just talk about how joins work. Okay, so so let's go ahead and look at some quick code for Wednesday. So before we get that far, were there any questions on week 4 or any questions as you're looking at week 5? Okay. Just a couple of quick things here. Again, this is a union command. I have the same select first name, last name from actor, where last name is like R, union all, select first name, last name for customer, or last name like R, order by last name. If I run this, it gives me all the last names beginning with R. Because I use union all, so I got 42 here. Let's see if I get rid of the all here. I take the all out, still 42. Remember, if I do union all, it gives me any duplicates that may be happening. Union just gives me everything. There's the first question on your exercises talks about this. If it's union, it returns all the unique values. If it's union all, it returns every value. So for example, if you had 2 sets, ending in P, L, M, N, O, right? And you had another set. P, Q, R, S, T. And I said union, right? I would get LMO, MLNO, P, QRST. Okay. If I said union all, I would get LMNOP, PQRST. This will look very familiar when you get to the exercises. I bring this up because this is one people frequently get wrong. Union all, I got the double P. Union, I just got the 1P. Okay. Now, this query here I put specifically because every time that you see someone doing an inner join, they're always doing a join on a foreign keyed column. Okay, you do not have to do a join on a foreign keyed column. For example, select last name as actor, last name as customer from actor, inner join customer on last name equals last name, order by last name. This is not a foreign keyed column. This is just a column that it has in common. The columns don't even have to say the same name. You can match on any column, whether it's foreign keyed, whether it has the same name, whatever, but you can match on it. So let's run this. And I'll get results. Alan, I'll get the last name, right? I can do this. There are columns that have nothing to do with each other. I'm not going to get any results. Oh, I did get results. Look at that. How funny is that? Oh, where last name equals first name. Oh, that's. I guess they're first. Wow. I guess they're first. Oh, Alan. Oh, that's funny. Alan, Tracy, and Wayne are last names and first names. How funny is that? I didn't realize. But here we get joins because we had matching. So I was matching the actor's last name to the customer's first name, and I had matches. Okay. So it doesn't matter what you do this on clause on, as long as they're the same data type and you stand some chance of getting results back. Okay. So let's look at the left join here. So here I'm going to get the actor's last name and the customer's first name from actor, left joining customer, where the actor's last name equals the customer's last name. So I've got a left join here. So I'm going to return everything from actor and only return the customer's last name where there's a match. So I'm going to have a lot of nulls here. Okay. So there's no Ackroyds, there's no Astairs or Baileys. All these guys don't exist in the customer table. So I got everything out from the actor table, but only where the customer table matched on that side. If I change this to a right join, it'll be the exact opposite. Okay. And here's my only matchings down here. Oh, because I'm ordering by actor's last name. I didn't change that. Change that here. Let me order by customer's last name. That'll make more sense when you look at it. There you go. So get it. No Abbeys, no Adams, no Alexander, no Allard, but there's 3 Allens that match. Okay. And that's fundamentally it. That's what the right and left joins do. That's how simple this is. Are there any questions? Everyone getting there? Everyone following this? Any questions?
Yes, I have a question.
Go for it.
I may be wrong, but it seems like when you use the joins and you also you can use the union for the same thing. Like, does that make any sense? Because I feel like I can use either one to accomplish what I need.
So
But
yeah.
what are the difference?
So with this way here, right? I theoretically see the big difference is, let's do this. I'm doing select last name from customer and last name from actor, right? So when I run this, I'm getting all the last names in one column, right? But I'm not comparing anything. I'm just saying, show me everything that ends in R, right? There's no massaging, there's no finesse. It's basically a shotgun approach. Just show me everything. When I'm using the joins, I'm asking it to think. I'm showing here, show me the last name of the actor and the last name of the customer, but only where they're the same, or last name equals first name. show me the last name of the actor, last name of the customer, but only where the last names are the same. Okay, you can't do that with a union. Unions just like give me everything. With your joins, you can finesse it. You can say, give me only what I want to see. Only show me where the last names are the same. Only show me where the dates are the same. Does that make sense?
Yes, thank you.
That's
So
what
it's
that's what-
just a bit more specific, that's
Yeah.
all.
Yeah, it's more granular. The word we like to use is granular. We can granularize the data. The better we're at taking the data and making it in a form that the end user can understand, the better we're doing our job. Let me see.
There is a part of the theory is that one is horizontal and the other one is vertical.
How do you mean?
I mean, that's what I read from the book.
Huh.
They say that union joint is horizontal and union is vertical.
That's interesting. Unions are vertical and joins are horizontal. I can kind of see where they're coming with that. It's an interesting way to look at it. I don't think I've ever shows you how long since I've read the book. But yeah, so I can see that where unions just grab everything and just bring it straight down to a line, and joins kind of spread it out across the thing. You know, let's make a so let's do this. Let me see what we got here. Film. Let's write one offhand here. Let's film category. Okay. So let's do okay. Select film. I don't want to do this. It gets tricky when you're using the inner joins because the outer joins. I'm not gonna write one on the fly on here because remember it's got to be where they're not matched up. And if I try to do anything that like film ID and film ID, they're all gonna match up. So I think maybe just leave it at this for right now. I can't think of anything offhand to do an outer join with. Yeah. I'll just set up. I'll just do more interesting inner joins next week. I'll set up the database, do some fancy ones. But I mean, this is basically what you need to know with them is that it's this. It shows you everything in the right column, in the right table, but only what matches in the left. Now, in everything but SQL, it's MySQL, you got this. A full outer join. And what that does, it returns everything from both tables, and where they don't match up, they put a null. This shouldn't work here. Yeah, it doesn't have full outer joins. Yeah, full joins don't work. Full join? Yeah, full joins don't work. So you only have your right and left. In Oracle and in MySQL and in MongoDB, full outer joins work. And that would just be, like I said, you'd see, well, it'll be this. Oh, why don't you do that? Oh.
Because you have two order by clauses in it, you're not allowed.
Nice catch. Nice catch. Who said that?
Me.
Nice, Jason. Good catch. Good catch. Okay. Nope, still doesn't like it. And so use a blue. Oh, okay. That's fine. We'll just get rid of the order by because we don't really care. I just want to show the results. There we are. That's what a full join looks like. it returns everything from both tables, but if it doesn't match, you get the null. I bet you I could do this though. Bet you that'll work. Yeah, they are. So there you go. So that's your full join. So it doesn't work in this is how you do make a full join in MySQL. But anyway. That's pretty much the code for this week. Not a whole lot new. Like I said, your exercises are going to be all about unions. I think there's 6 questions, and I think maybe one of them has to do with an inner join. Everything else is union. Any questions? All right.
There are other operators, the except,
Except doesn't work in MySQL.
okay. And
So except XCEPT doesn't work in MySQL, and intersect is the other one, and that's just an inner
Yes.
join. That's really just an inner join. So whatever you do with an intersect, you do in an inner join. Intersect doesn't work in MySQL either. Those two are, which and this is and I think they finally given me the ability to fix the course. Because we shouldn't be talking about these two things, because it's just confusing. Because they don't, you can't use them here. So why would they be here?
I was gonna say
Yes.
the exact same
Yeah.
thing. It's getting really confusing, trying to figure out what works and what doesn't.
And
the
it's,
book,
go ahead.
the writer, he has, you know, all the query there, but it even states, you know, I'm not using MySQL in the prompt because this is not going to work.
Yeah,
So, and
yeah.
when I read that, I said, well, okay, so what's happening?
The only logical reason I can come up with them doing this is because MySQL is not, how do I put this? MySQL is not an industry standard. It is a small database. It houses small databases. It can't be used for large production databases. Sometimes when you're working in field or in a company, you'll find that 1 or 2 applications using MySQL because it's a small application that maybe has like 1 or 2 users and maybe a database that doesn't exceed 250, 500 gig, right? So you have this little database here. Like, for example, in my company, we have 1 application in the entire company that uses question down. Oh, sorry. Oh, Mariana, I just haven't gotten to it yet. I'll look at it real quick tonight, but it's probably a good idea. I haven't run into a bad idea yet. So, so you're good. Okay. Go for it. Yeah. Sometimes I get bad about, I've got to get better at grading the papers because I forget you guys need the input on them pretty right away because of the project. So my goal this semester is to get the papers done by the latest Monday, which I failed this week. So I apologize for that, but hopefully I'll have 4 graded tomorrow and I'll get 5 graded on Monday. That's my goal. Just so you know. Yeah, so as I was saying, my company, we have one application that uses MySQL. We're desperately trying to get rid of it, but we don't want to put it on like something that, because MySQL is free. No, you're not charged to use it. So we don't want to throw it on Oracle that costs like $1.2 million to have an install on it, or Microsoft SQL Server that has like, it costs like 500 grand to have an installation of it running, you know? So for what you guys are doing for like your web apps and stuff like here, you'll use MySQL, you get used to it. But one day you'll run into Oracle, or you'll run into Microsoft SQL Server, and then these commands will work there. So it's kind of like, hey, one day you might see these commands. So this is what they do. But yeah, there's a couple of commands we're going to run into here that don't work. But they'll talk about them anyway. And I get that it's confusing. So, and it's in the book, which makes it even weirder because the book's like, hey, here's intersect and how to use it. By the way, you can't. So, anywho. Yeah, so those don't actually work. But like intersect is just an inner join, and except is weird. Except like if I did it here, it'd be like show me every last name and actor except the ones that show up here. So it's kind of like not in. So I would do like, you know, the way I would do, yeah,
minus instead.
well, what I would do if I want to do that the except, I would do this.
Only just that.
And then open the parentheses, and then I bring this up over here. And then do that. So that's how you do the accept.
Tricky.
Yeah. And so the funny thing, so if you look at it here, you're like, one might think I've got last name here and I've got last name here. Why don't I have to do the thing with the qualifying where this has C last name and this is A last name? It's because this query is run separately from everything else. It's not run at the same time as this. So it only sees this one query. So it only sees this last name. And then when this is done, it does everything else. So it's just like math sometimes. Anything parentheses runs first when you're doing subqueries. So, all right. What did you send here?
Oh, it was just a little diagram of what we were talking about earlier.
Oh, okay. Cool. Yeah. So, so as you look to your final projects, you'll need your inner joins and your outer joins to write all the queries for your case studies. As we get into like week 9 and 10, I will stop talking about the code. As of week 9, I think week 9. In week 9, we stopped dealing with code on the weekly lessons because we started talking about indexes. We started talking about fragmentation. We started talking about things that you can't write code for. So 9, 10, 11, 12, might be 10, 11, 12, 13, and 4. 10, 11, 12, and 13, we don't deal with code. 9 is like last week of code. But in these Wednesday meetings, we're gonna stop talking code. We're gonna start talking code from lesson. We're gonna start writing code for case studies on one of the things that I make. So speaking of which, if there are no questions on this, we'll go ahead and play with the idea of designing a database real quick.
I have another question.
Hit me.
Okay, it's not about the database, but it's something that I'm trying to do.
Yep.
If I have a column and only want the rows that are numbers, how can I get it? You know, we have like 1,000 records, but only need the ones that have numbers in it.
You got some tricky questions, man. So basically what's going to happen is you have a column that's a varchar or a text
It's a
column.
varchar.
It's a varchar and it's got numbers in
It's a
it.
varchar. I have numbers
So-
and I have letters, but only need the ones that
Have
don't
numbers.
have letters. That don't have numbers, only letters.
So you want the ones that don't have numbers, only letters.
That's correct.
How would you do that quickly and easily without a ridiculous amount of code? I'm gonna have to think about that one. You're asking the tough questions, man. You're also the one who wants to know how to talk to databases from between databases.
Yeah, that's correct. I'm still waiting for my. Help.
You're gonna get that by week 12. I got that. That's something I got to do. Because I have to look up to see how to do it in MySQL. I've never done it in MySQL before. But I will find a way to do it. Any other database, I know how to do it quick and easy. But MySQL, I gotta look that up. So I gotta take another note. I gotta figure out, because my instinct would be just to push the error and convert the do a convert to a text, convert the no, that would work because numbers can be considered text. Huh. That's a tricky one. I owe you that one. Okay. I'll find an answer by next week on how to do that. That's a good one, man. All right.
Thank you.
Yeah, no problem. Just keep the hard questions coming. All right. Any more hard questions for me? Nah, any other questions? Okay, let's go ahead and make a new model here. Okay. I wanted to play with the idea of making this database for like a shoe company. Okay, so if I'm gonna make this database for a shoe, like I'm gonna open up a shoe store. What does that want to work for me? So here's the table. So my first table is gonna just be called shoe. And then I'll have a shoe ID. And then I'll have a style. Sure. Style. Okay. And then I would have a color. And then I would have a size. Okay. And then I would have a maker, brand. Okay, I'd have a brand. And then I would have, what else would I have?
Name.
What name? Oh yeah, name. Shoe name. Okay. That's good. I like that. Okay. So I think that's a good start here. So let's look at this. Oh, maybe since the sorted quantity, how many shoes we have on hand of that particular brand. Okay. So let's look at this. Style, color, size, brand, shoe, and quantity. And SKU or UPC. There. UPC code. That's another good one. Okay. Okay. Anything else? Anything else that this column, this table would need to identify a shoe? Because it's still normalized. Everything here is, as we can see it right now, it makes sense. It deals directly with the shoe in stock.
The arch support.
Arch
Padding.
support. Arch supports. Supports. Oh, and then materials. You want to know what their steams are made out of?
You could do a description as well.
Okay, description. Okay. Okay, I like it. Okay. Anything else? Okay, so let's look down the table here. So let's go style. We have a number of different styles. I don't know what they would be, but you know, so, and we've got color. So these are both indicative of here. Now let's remember we talked last week and you said if we had some information that was unique to the unique to each ID, but we wanted to make sure that someone didn't type it in wrong, we put it in a separate table. So style and color and brand kind of fall within that, right? Because someone's got to input this data and we don't want them typing the name. We don't want them typing blue because they might misspell it and call it BLEU or something like that. And then we have one blue spelled wrong and 57 blues that are correct, right? Also with color, if you think about it, certain styles of sneakers will be 2 colors. So that's it. So let's go. So style, we're gonna make a new table and call it style. And we're gonna do it. No. We're gonna keep that shoe. Thank you. Go here. Let's make this style. And we'll have style name. A style ID first. And we'll have style name. Okay. And then we'll go ahead and delete the style column out of here. And we'll go ahead and create that. Okay. So now we've got a style ID into shoes. That way we're keeping our data integrity. We'll put the values here and then people will choose from a drop-down list. So they won't have to input or try to type in the name of the style. We won't have to play guessing games. Now that works. So now color. So one shoe might have many colors. So what we'd have to do is we have to create a color table. And then we do a color ID. And then we'd add color name. Okay, and because one shoe would have many colors and one color would have many shoes attached to it, we need to do one of these. Where it says shoe has color. That way one shoe can have many colors. Okay. And then one shoe style might have, so the shoe ID will link to the style ID, and then we'll have, so we don't have to, so we don't, if we want to see what styles came in red, so this is kind of an advanced thing. So if I'm writing a query and I want to know what styles of shoes, let's make a style name up, high tops. Let's see, I want to know what high tops came in red, right? I can do a search on style for high tops. And since it links to these tables, I can find out which ones come in red. I don't care about what brand it is. I just want to know what styles, because a lot of different brands, you make high tops. Okay. So there's that. So we got those going on. That's good. Brand, we want to get rid of the color column here too. So the color column can go. Delete. Okay, brand, we definitely want to make a brand table. We don't want the brand sitting here. So we're gonna do the same thing as we do with style. Let's move you down here. Okay, let's move you down over here. Let's make a brand table. If anyone gets lost in what I'm doing or has a question or an idea, just please shout it out. And we have a brand ID. And we have a brand name. All right, and we'll go ahead and go here, and we'll get rid of our brands column. And we'll do this. And now we've got our brand. And now we can do a query to see which style comes in what brand. So what brands have high tops? What brands have high tops that are red? Okay. So we got the brands. Oh, I forgot over brand cost. Okay. So size. Let's put it to the group. What do we need to do with size? Do we leave it there or do we separate into a different table?
Different table.
I would separate it into a separate table because you got men's sizes, kids' sizes, women's sizes.
Right. So that's a good point. So let's make a new size table over here. Okay. I'll make this size ID. We'll call it size, and we'll have size ID. And then we'll have size. Right. I couldn't say gender because it's male, female, and kids. What would we call that? Category? No. We'll call it category for right now because I can't think of what else to call it. But that would be men, women, kids. So that's that. Okay, so now, what's my relationship between these table going to be? What's my relationship between the shoe table going to be? Is it 1-to-1, 1-to-many, many-to-many? What's this relationship going to be?
Many to many.
Many. So I need to make a many because one shoe will have many sizes and one size will have many shoes. So one of these guys. Okay. Now, let's get rid of shoes to the size here. Okay. Delete. Now, are there any columns in the shoe table that I could add to my shoe has size table? That would make sense.
Add brand.
Well, with brand, so brand kind of belongs here because brand ties directly to the shoe. So I want that, right? But there is a column here that makes more sense to go over here than it does to stay over here.
Could be quantity.
Quantity is exactly correct. Quantity. So why would quantity go over here as opposed to staying in this table? Because my quantity of my shoes is going to be based on the size. I have 27 size 6 Nike high tops. So here we definitely want our quantity. Okay. And over here we can add our price because price needs to be over here. Price. Okay. So we'll get quantities right there. Shoe name, UPC, arch support, material, description, style, and then price. So are there any other columns in here that we need to consider moving out to a different table? Or is everything good? Is everything normalized?
I would say material. Material.
Yes, me too. I think material.
I think material would have leather or
Sure. Absolute materials. So we need a material table. And we're not going to change the name of the shoe table because we keep wanting to do that. What am I missing with here? Brand ID. No, let's shoot to it. Okay. So go back over here. So we definitely want a material table. And a material ID. And then material name. And what's the relationship going to be?
many to many.
Absolutely, it's going to be many to many because one shoe can have many materials and one material can have many shoes. So we're going to do many. All right. Here, let's put you over here. Right over here. Okay. Let's get rid of our material. All right. Anything else that you see here that, so let's look at our shoe table. All we really have left is shoe name, UPC, arc support, and price. Are there any other columns here that should be moved into another table? Or another price?
Yes.
Where would you put price in a different table?
Because price would depend on size, and price would depend on material.
You could also have regular price, sale price, discount.
So this is where the interesting thing is going. So this is where we're gonna get a little bit deep dive in price. So I don't know.
Maybe
So
maybe the if it is the industry building, constructing, building, I don't know, making the shoe to calculate maybe earnings or something like that. But if this is a store, I think it is not.
So this is a store. Okay. So here's interesting. So one person said because of size and material, the price may be different. One person said because there was a sale price, right? So we have a whole section of this that's not being made yet. That would be the retail side of it, keeping track of orders and sales and stuff like that, right? So just right now for the shoe inventory side, MSRP is manufacturer suggested retail price. That's what they suggest that we pay for it, what we charge for, right? As far as I know, in shoes anyway, the suggested retail price does not vary with size or with materials, because every shoe is made the same. Okay. So now if it were the case where the price changed on materials and stuff like that, then we would definitely find a way to pull that out. Like if they made like if Nike made a Air Jordan high top that was made of leather, one was made of leather and one was made of plastic and one was made of, I don't know, kangaroo skin, right? For better jumping. Then we'd have 3 different materials and those would definitely be 3 different prices, right?
Ergodry.
Yeah. So that'd be something else. But so if we did that, we would have to tie the price. It'd be interesting. So we'd have to do, if we did it that way, we'd have to create a table, a price table. So let's play with this for a second. Let's make a table here. Table. We'll call it price.
It's like selling knockoff shoes and the genuine shoe in the same store.
Yeah, like a class A or class B shoes.
Well, so if it was selling a knockoff shoe, then it would be a different brand. So if you like, for example, you go into your friendly neighborhood Walmart and you've got the Nike shoe there, and then you've got the Crate and Barrel shoe, that's the exact, it looks exactly the same, but there's 2 different brands. I'm saying like Nike makes 2 versions of the same shoe. It's the same style, it's the same brand. Oh, and here's
that's what I mean by knockoff, is that they look the same and they
Right.
claim to be the same shoe, but they're actually not genuine.
And here's where I think the difference is, the way we got this. This is going to be the dividing factor in it, the UPC, because if it's 2 different versions of the shoe, they look the same, but there's some different, they're going to have a different UPC code. So that's how the pricing, that's why this is going to work with the price and this being here. So the UPC, is anyone from, I got a really dumb question. Anyone who's not from the States, you have barcodes on stuff in like other countries, right?
Yeah.
Okay, so that was a really stupid question. I apologize for my ignorance. But I don't know what they do. I've only left the country once. So because the UPC is here, that's a unique identifier, and that is going to link to MSRP, because if you've got the same brand, the same style, but different materials, you're gonna have a different barcode on that. Okay, so price wouldn't be this, so price would stay where it is. Now, as far as sale price was concerned, I don't want to put a sale price here. I want the sale price to be in the sales table. I want to record the price that I sold it for. So somewhere I've got a table called orders, and in there it's going to record the price. This price here is going to be what I chart, what's the non-sale price. Okay. The real price, if you will. So I wouldn't have sale price in there. But there is definitely one column I would pull off into another table, but I wouldn't call it what the column is called. And that's arch support. I wouldn't have an arch support column because that's a feature of a shoe. And shoes have many features. And if I put arch support here, and then I had another one that was memory foam, or I had one that was one of those pump shoes, or I had one that was like lights up, you know, a light up shoe, then I have to start adding new columns. So what I want to do here is I want to make a table. I'm going to call it features.
You would want to take out arch support and replace it with features.
Yep.
Is
Because arch support is a feature of the shoe. And like I said, you've got other features. You've got arch support, you've got memory foam, you've got you know, lights, you've got any number of things that could be a feature of a shoe, right? So, and I don't want to, like we talked about last week, I don't want to add a column. Every time I add a new feature, I don't want to add a column to the shoe table. I don't want to change the structure of my table unless I absolutely have to. There's no way around it, right? So arch support is a feature, so I'm going to go ahead and remove that from this table. Right? And I've got my feature table, and I'll have my feature ID, and I'll have my feature name. And then what's my relationship between shoe and feature going to be?
one to many.
I would think many to many.
Many to many, because one shoe can have many features because it could have memory foam, it could have arch support, it could have narrow, it could have lights, it could have roller skates on it. And one feature will have many shoes, so we'll definitely have many to many here. The hardest part about your ERD is getting it so you can see everything cleanly. Okay. There we are. Now we're getting somewhere. All right. There we are. That's better. Okay. So we started with one table and we're at 4, 8, 11. And like I said, this is just the inventory for the shoes. We haven't even started the customer side of the database. We haven't started the order side of the database. We haven't started the employee side of the database. So were you all able to follow the natural evolution from one table into 11? And does it make sense? Feel free to say no. Okay. So this is kind of what you have to do. I know some of you have already started doing your tables for your ERD for your projects, which is great. Doing that on week 4 and 5 is really ahead of the game. But this is what you do. You find one table that you know is going to be the root table of everything you're trying to do. In this case, I want to make a shoe database. So I need a shoe table. And then I just start naming out the columns I need for that table. And then I look through each column saying, okay, does this make sense to be here? Or does it need to be another table? do I want style? Is style one-to-one? Style is absolutely one-to-one, but I worry that someone might type the style in wrong, either when they're inputting the data on my form, on my application, or when they're searching for it. So I want to make it simple. So I want to do a drop-down box. So I make a style table. The same thing with brands. You know, I don't want them trying to type in Nike because it's easy to misspell Nike or Adidas or whatever, Asics or whatever, right? Shoes have size, absolutely. So I can't put it here because one shoe is going to have multiple sizes. So I can't have like 9, 10, 11, 12, 13 kids, 9, 10, 11, 13, you know, because we know there's kids, women's, and men's sizes. So here I'll do shoe has size. And I had quantity over here, but quantity makes more sense over here because each size, each shoe is going to have a quantity based on its size. I don't care that I've got 736 Nike high tops. I care that what I got by size, you know, so I do that. Same thing with color. One shoe might have 1 or 2 or 3 or 4 colors. So I want to make sure I have that separate. Also, I have the ability to use a drop-down box so people aren't typing in the name of the color. Materials, same thing. So this, it just evolves out of that. Does that make sense for everybody? All right,
Yes.
excellent. So, and this is, and like I said, this is why the final project is way more fun than the final exam. And it might seem terrifying at first because you're trying to do this, but it really is just a logical progression of how data flows. And when you look at this, so when you look at this and you're saying like, you know, what kind of case studies would I need on this? Well, I need to know what brands of shoe have the same style. So I need to know what brands share the same style. So if someone comes looking for high tops, I can direct them to whatever brands. Another case study would be, I want to know what sizes we keep in stock the most. So I can find that from here.
What color is more likely to be sold?
What color is more likely to be sold? What color is the most common amongst all the shoes?
Yes.
Right. So what feature is the most common amongst all the shoes? You know, so that, you know, if we built this out, it would be an interesting exercise for this class. And I'm going to save this and maybe we'll continue and like to build out like the orders, to build this out to a full database. Because I think my guess, if this were a fully functioning database, we'd probably be at 70-ish tables if we included customers and orders and everything like that, right? Yeah, so, you know, what materials are mostly used to make high tops, you know? You can start thinking that. So, and again, your case studies for your database are like, what questions would you ask to get information out that your end user might want? You know, one person wants to do their every semester people do things that are close to them. So people do on food storage. And last semester, it was interesting, they linked a food storage database to a recipes database. So they put their recipes in the database and their food storage in the database, and they would write queries like, what recipes require, what can I make? But the best one there was a really complicated query. What recipes can I make with what I have in food storage right now? So I had to look at what they had in their food storage and then compare it to the recipes. And it ended up being like a 22 table. They went crazy. It was like a 22 table diagram, but you can see how like complex this could be, right? You know, you might, another one here, like what shoes are we low in stock on? Like what brands do we have less than 20 pairs in so we can reorder them? Right? Okay. So we are at the bottom of the hour. We're at 10:30. So if there are no other questions, I will end it here. As always, I'll put the code on the lesson with the video, which I'm gonna try to get up tonight. I had some problems last week getting the file converted. So hopefully I fixed that problem. And we'll
Thank
see.
you, Don.
You're welcome. And Gabriel, I owe you those answers. I will get them to you. The joining tables, not for a while, but and not Maria, Mariana had a good idea on, she said, making a regular expression, take out the numbers and just look for letters. That is possible. That is tricky though. So I'll have to look into that and see if I can't find some code to do that for you to show you. And I'll do that for next week. All right. If there's nothing else, you guys have a great night and I'll talk to you next week.
Thanks. Good night.
Good night. Bye.